Hello students. Now today we will discuss about K-means clustering and K-nearest neighbor search. For this now K-means clustering, this is the program which we have given you. But before going to this program, first of all I will explain this, and in this explanation we are covering this part also. Okay. So here first of all we need this scikit-learn. If it is not installed in your machine, then you have to open the command prompt, and in command prompt give this command. Okay, install pip install sklearn scikit-learn package. After this, go to the file menu, then settings, and in this project interpreter, click on this plus sign, and here you have to check scikit-learn and then click on install package. I have already installed this, that's why it is showing here scikit-learn, and after installation you write this program. Now basically K-means clustering, if we have the data, then separating this data, okay, that is called as a clustering. We are trying to collect the group of the data which is having similar properties. Here directly we are using this ready-made function present into the scikit-learn package. So from here initially we are importing K-means clustering package from scikit-learn. Then we are using NumPy for the data. Initially we have considered this data on our own initially, and this data we want to combine into the clusters. To combine into the clusters, that means we are trying to combine similar data. To combine data into the clusters, we have to access K-means. Now to this K-means function, initially we have to send how many clusters we want to create. That here initially we want to create two number of clusters, and then here random state is 0. Compulsory we have to mention random state, otherwise every time it will generate the random numbers, different random numbers, and it might give you the wrong answer. So to get the correct answer, every time we need the same random values, and for the same random values we have to give random state equal to 0. So it starts one thread, and same thread is used every time when you run the program, and it will generate same value every time if you run the program. If you don't mention this, it creates new thread for every execution and will give you wrong values. So here we are calling this K-means, and to this K-means we are trying to fit with X. Okay, this we will discuss afterwards. After this generation of a cluster, we are trying to print here cluster values. If you run this program, I will show you the execution, and then we will discuss about this. Okay, so now when you run this program, this is nothing but the output of K-means labels. Now this label indicates whatever points or the data which we have provided for the clustering, that data belongs to which cluster. Now here we have mentioned that we want to create the two clusters, so it will consider cluster 0 and cluster 1, and depending upon this data to print here, I have used here 1 2 1 4 1 0 10 2 10 4 and 10 10. This is same as this I have used here just for the printing purpose. So 1 comma 2 belongs to cluster number 1, 1 comma 4 belongs to cluster number 1, 10 comma 0 belongs to cluster number 0. Like this it gives you the label that data belongs to which cluster number. Cluster number starts with 0. So this is this. Now each cluster is having one center point, and print that center points we use cluster centers. Now first cluster is having center point as 10 and 2, second cluster is having center point as 1 and 2. Okay, so this is 10 and 2, and then 1 and 2, and then we are providing here data that we want to check in which cluster this 0 0 belongs and this 12 and 3 belongs, and for that we call the predict method of this k-means which we have created here, instance which we have created here for the k-means. So k-means.predict, it takes the data and it indicates or it gives you in which cluster that data belongs. So here we have mentioned 2 points 0 0 and 12 3. So this k-means predict program will give you this 0 0 belongs to which cluster and 12 3 belongs to which cluster into the VAR, and then we are printing this VAR. Check this VAR 1 and 0. So this 0 0 belongs to cluster number 1 and 12 3 belongs to cluster number 0. If you check this, this is 10 2, 10 4, 10 0, this is belongs to cluster number 0, and this 1 2 1 4 1 0, this belongs to cluster number 1. So by seeing this 0 0, it is nearer to this, so it belongs to cluster number 1. And if you check this, this is the values for cluster number 0, and so this 12 3 belongs to cluster number 0. So centroid of cluster number 0 is 10 2, and this is nearer to 10 2, and centroid of cluster number 1 is 1 2, and this is nearer to 1 2. So this gives you the centroids and it gives you the predictive value. Now we will go to the next part. Why we have choose this cluster number 2, number of clusters as a 2. There is a method to find out how many clusters will be the proper number of clusters for a given set of values. Now we will discuss on that. So for the discussion on that, I will mark this as a non-executable. Select this and press Ctrl// and then I will open this program. Okay. One more part is there. Okay. Now here we have taken a sample data. So to generate sample numbers from the data set, we have imported make blocks. Make blocks is a ready-made, you can say, function provided in scikit-learn dataset sample generator which generates the numbers. Okay. Now here we are calling this function, and to this function we are passing this value, that is we want to generate 300 sample values. Those values, number of clusters, number of centers we want as a 4. By considering 4 main values, we want to generate 300 values. Clustered standard is 0.60. The values which are generated, they must be close to each other so that we will form the proper clusters. And then random state is equal to 0. If you execute this program number of times, it gives you same values, same sample of 300. So I am time being making here as a 100. Okay. Now to get proper number of clusters, how many clusters are proper, we have to generate number of clusters for different number of centers. How many clusters you want? Okay. So this previous k-means, to this k-means we are passing number of clusters only here 2, but now this, to create the number of clusters, we are executing this using for loop. So for I in range 1 to 11, so it will execute from 1 to 10. So initially value of I is 1, so by considering single cluster it will execute the k-means program. Then I becomes 2, by considering 2 number of clusters it will execute the k-means. Then I becomes 3, it will consider number of clusters as 3, it will execute the program. Then it will take value of I as 4, it will consider number of clusters and 4 as 4, and then it will try to execute it. Like this it will go on. And for the same, every time executing k-means program with same x. Okay, so here number of clusters we are giving, init it with k dash means plus plus. Here we can provide random also and k dash mean plus plus also. Now here if we give k means plus plus, the centroid values which it consider it will consider proper centroid values, optimized centroid values, so that number of iterations or number of values which it considers as a proper. If you consider, you can mention here random. If you mention here random, it will take any random value from your x, and considering that, it will prepare your clusters. So to get a best cluster, here we mention k-means init. Then number of iterations, how many times that clustering program will execute, that is mentioned 300 times. N init as 10. So here, by considering cluster as a 1, also consider 4. By considering cluster as a 2 or 3, whatever it is, whatever value of I, it will try to execute this k-means 10 number of times, and from 10 number of times, the best cluster which is created, or best values, it will consider as a k-means. Okay, and every time it will iterate for 300 times. So it will try to create your k-means clustering, or clustering model, k-means clustering model, for 10 times, and every k-mean cluster, it is performed 300 iterations. So 300 iterations it will consider every time, and it will generate such 10 clusters, or 10 cluster values, and from that best it gives to k-means. Okay, and then by considering this generated values, we are trying to fit our x, and whatever fit, and from that we are getting here criteria. Okay, and then by using this, we are trying to, the water values which are generated, we are trying to put this into the plot. Now if we execute this program, and if you check the plot, okay, if you plot this, it will give you graph like this. Okay, so this is with cluster 1, this is with cluster 2, this value is with cluster 3, then this value is cluster 4, 5, 6, 7, 8, 9, 10. It will execute from range from 1 to 11, that means it will create 1 to 10 if it is one cluster, two cluster, three cluster, like this. And here if you check this 4, from this 4, this is reducing, that is, this gives you how many iterations, or what is the difference between the values of that cluster. Here there is a large difference between the values, and here this is a small difference, so drastically it changes over here in 4. So we will consider number of clusters as a 4, or you can mention randomly also. But properly, this, first of all, we have to execute this elbow method to get proper number of clusters, and once you get the proper number of clusters, then that value you can provide in your program. So that's why we are considering here 4. Now stop this program, cancel, means I will make this as a non-executable. Now I will go to the actual program. So here, check this program first. Now we are trying to execute k-means. Remaining part we have not mentioned here, though we have not mentioned. It will take init as a k-means, maximum iterations and 3 added, and n init is equal to 10. This is a by default values. We can mention our own values just for the explanation. Initially we have mentioned this. If you don't mention this, it will take this as a by default, no problem. So here k-means is equal to this. I will give here a random state equal to 0, because same thread I want to use every time when I execute this. So here we are trying to create the clustering object with number of clusters as a 4, and this k-means we are using for x. Okay, and for this x we are predicting y k-means, that means clusters, in which cluster it belongs to. Initially we are creating clusters, and then we are trying to fit x within it, and then with every x of value of x, we are trying to mention, we are trying to uh, form the clusters for x, or this per corresponding value, it belongs to which cluster. So initially 4 clusters will be formed with corresponding values, and then this 4 values we are trying to fit for this data x, the data which is generated over here. If you want to check the data, you can check the data over here, no problem. If you give print x, it will display you the values. Okay, and then we fit this, and then we are trying to predict value of y. This y is initial cluster values which is given over here. Okay, and with k-means, what is the value that we are mentioning here. After generating the clusters, we can get the centroids using this k-means dot clusters. Then we are printing this centroids, and then we are printing labels also. This for every x, what is the cluster, in which cluster it belongs. Now if we execute this, okay, now this is output. Initially, these are the values which are generated by our program. This is generated by this make blobs. Okay, these are the values, and these are the cluster values, in which cluster that value belongs to. If you check here, it will give you 0 to 3 because we have given number of centers as a 4. Then we are executing our k-means program on that values, and after that values we are predicting corresponding values of y. What will be the values of y? Okay, that is in y means, y k-means every value. Then we are fetching the centroids just to print the centroids. Now we have 4 clusters, and this is centroid of cluster number 0, this is the centroid of cluster number 1, this is the centroid of cluster number 2, and this is the centroid of cluster number 3. And for this value, every value, so if you consider this initial value, for this value, initially cluster given by the system by this make block is 0, and what is given by our program is 2. For second value of x, these are 300 values. Okay, so for the second value, the cluster number which is given by make blob is 3, and our program which is generated is 1. This depends upon the centroid. So this is a given, initially given by your make blob program, where it is, okay, make blobs program. Initially it assigns cluster to each and every value, and this is the value which is given by the cluster. Okay, this is actual values which is given by the clusters, and these values we are storing into the y k-means. Okay, now we will try to plot this. Okay, now here this is taken as a first row, 0th column, and this is a first column. This indicates all the rows, and this color depending upon the cluster, this cluster we want the values. That's why we are fetching here predicting value, predicting the cluster for each and every value here. Okay, this value of x that we are considering here to get the same color, this s is 50, that means the size is 50. Then we are trying to print, if you consider this initially. Okay, now if we execute this program, okay, this is how it gives you. Okay, and this is x values, this is y values, this is what we have given here is 0, that is x axis, and 1 is y axis. Okay, these values, this is value 0 and this is value 1. So we are getting this. Okay, so this color combination, it comes because of this y. For 0 it assigns one color, for 2 it assigns one color, for 3 it assigns one color, and depending upon color it works because we have mentioned here, that is color combination. Now if we add this statement into the program, it will try to display your centroids also with red color, and its size is little bit more. Here we have mentioned 50, here I am mentioning as 30, and alpha is equal to 0.50. It gives you transparency. Check here, this is a red is now centroid. Now if we make this alpha as 0.9, it must be between 0 to 9. Okay, 0 means 100% transparent, 1 means fully occupied, no transparency. Now if I give here, now here we are executing 4 5 times, so to get every time same value we are mentioning here random as a 0. So check here, this is a dark red spot, you will getting it, and the size is little bit more than this. So we have mentioned here as a 70, and for remaining we have mentioned as a 50. So this is how we can mention the clusters. For new value also you can predict here, you can call the predict for the new value. This is for x value. Once your cluster is created, you can call this for the new value. You can call here new y, or you can say predict y for the value of can I give here 0.235 comma 6. Just check it. Okay, this is not curly bracket, this must be square brackets. And then I will try to print new y. Okay, just I will check it. Okay, after creation of the clusters and we get the centroids and labels and all, if you want to check the new value which belongs, it should belong to which cluster, then here I am creating one point. This is one point. Now this point I have created by looking at the clusters. So this is minus 1.234, so it will come to nearer to this, and this is a 7, so I have given this as a 6. You can give here as a 7 also, no problem. So it will belongs to 0 1 2 3, so it belongs to cluster number 1. Okay, 0 1. Okay, and then we are, after creating this point, we are trying to predict in which clusters it should belong. That value we are taking into the new y, and then we are printing new y. And this is the original cluster, this is the centroids, and the new point which we have taken here, and that new point we are displaying with the help of G color and with its size as 100. Now if we execute this program, check here, this value which we have mentioned here, it is nearer to this centroid, minus 1.2347. This is minus 1.24, and this is 7. Now if we change this value, now I will come to this cluster, now nearer to this cluster. So I have to mention here 0.824, and this is 4, so I will mention here 5. If it is 1 point something, it goes to the cluster number 0. So it is a 0.8, so it will come back, it will come to the cluster number 2. Okay. You can give predicted. Okay, now if I run this, okay, check here, predicted cluster number 2 for this point. Okay, so it is coming over here. So like this KMeans is used to create your clusters, and once the clusters are created, okay, you can predict the new value also. New value, predict the new value in the sense in which cluster that value will belongs to. Okay, like this we can work with the K-means clustering. Here I have explained the program, I have not explained what is K-means and all, how it works and all, because I think it is there in your theory part. So I am explaining only the program. Same program is taken over here. this is just to find out the number of clusters, and this is for the values. You have to write this program in your journal, or you can write step by step. What is the use of this program? Write this program. What is the output of this program? And then this program and the output of the same program. Okay. So in this k-means clustering, you have to write two part. First part, second part. First part is to find out number of clusters. That is this part. And then by using this number, this is the second part. Okay. Try this. Thank you.